learn something about the MCU, or we call the single chip microcontroller. MCU microcontroller unit means as the same the single chip microcomputer. Yeah, microcomputer. And the title of the class is Electromechanical Microcontroller Technology. Means many machines is integration of machine and electrical. Yeah. Now just as the bomb is integration of machine and electronic. Yeah, Yeah. So we learn this class to learn to how to use the microcontroller to control the machine. Yeah. But as the first class, you need to know something, the basic knowledge about the microcontroller. Yeah. Today we will introduce the chapter 1, the introduction to computer and microcontroller. Firstly, we introduce something about the history of the computer. Initially, the word computer refers to a person who performs the task of computation or calculation. By the end of the 19th century, the same word referred to a machine that performs the task of computation or calculation. Now, we know the word computation is a machine who performs the task of computation or calculation. Computer equal to hardware plus software. A computer, if you have a computer but your computer have no software, you can do nothing. You can do nothing. So the hardware and the software must work together. Computer hardware is based on the binary digital logical. Binary digital logical is 0, 1. Invented by Claude Shannon in 1933. Binary digital logical is based on the serial Boolean algebra. Just 1, 0, 4 or truth. False or truth. Just two status. Information unit is used in computer. Bit, byte, word, double word. You know something about this?
Yes, a little bit. Actually, 8-bit equal to 1 byte.
8-bit is 1 byte. Yeah. Very good.
Is that computer hardware or software? Computer software
Computer software
is based on binary digital logic.
But it's based on binary.
Is hardware or software?
Computer hardware is based on binary digital logical. Hardware is
binary digital.
Is it hardware or software?
You mean this one? Based on the binary digital logical. The first computer is hardware computer. It has no software. They use the hardware to represent the 0 or 1. So the hardware computer is based on the binary digital logical. Just two status 0 or 1, 0 or 1. Yeah. This is very earlier. This is the information unit. Information unit is the computer make operation. Operation can make the unit change the state. Bit is only one digit. Byte 8 bit. Byte is 8 bit. 8 digit. Yeah. Word maybe 2 bytes. Maybe 2 bytes. Maybe some computer give 4 or 2, but 8 bytes is used for very frequency. Yeah. Double word means two word. Yeah, 2 words.
64.
Yeah. When the computer make operation, if the computer operating as a double word, the computer change the two word, change the 2 word state. Yeah. If we want to learn the MCU very good, we must understand this
MCQ questions.
The sequence. When we program a software, we operate byte, bit, word, or double word. Yeah. Next, we introduce computer hardware. Computer hardware consists of processor, input devices, output devices, and memory. Maybe you have your computer. Yeah, you have a computer, so you know something about the CPU, the keyboard, the mouse, the LED display. These are the hardware of the computer. Processor is designed to execute a set of machine instruction. Machine instruction is tell the computer how to work or do something. Machine instruction. A machine instruction is a sequence of zeros or ones, which can command the processor to perform certain operation. Just tell the processor do something. Memory is used to hold the program to be executed and the data to be processed. The memory stores the program and the data and the program used. Input devices allow data to be entered to be processed by the processor. Input devices just like a keyboard, the mouse. Yeah, enter the program. Output devices provide the feedback to user by displaying the program execution results. Just the LED, your computer LED. Something the printer can output the results on the paper. if you have your computer, you know some hardware. You can see them. Yeah. Computer software. Software is a program to be executed by the computer hardware. Software is a program to be executed by the computer hardware. Means software command the hardware to how to work. Yeah, to work. A program consists of a sequence machine instruction. Yeah, if you have a program is many machine instruction. Machine instruction equal to opcode and operand. Opcode is a command. Operand is a number. Tell the computer do something. So if you program a software, you must include opcode and operand. Stored program concept is the most important feature of the computer. A different computer has a different stored program concept. Yeah. When we tell you something about computer architecture, you know something different about the memory. By changing the stored program, the computer hardware can perform an limited number of operations. If you change the program, the computer can do something else. So, especially the a single chip computer is very small, just do one job. So if you change the program, it do something else. The earliest computer program is changing the wires and the switches of the hardware. The earliest computer just the hardware computer. So if you want to change the function of the computer, you must change the wire. You must change the wire. Today's program are represented as files of text. Today's program is something written on a file in files. So if you want to change the program, you just modify the files. You needn't to change the hardware. You didn't change the hardware. So it's very easy. Computer architecture. There's two computer architecture. This means hardware architecture. In 1945, John Newman proposed the stored program architecture. Stored program architecture is also called Von Neumann architecture. Stored program architecture, the data and the program are stored in the same memory. You need to remember this sentence. Data and the program are stored in the same memory. This is Von Neumann architecture. There's a different architecture in Harvard architecture. In which data and the program are stored in separate memory. Our PC is Von Neumann architecture, but the single chip microcomputer is Harvard architecture. Yeah. You know, when the PC is running, the load the OS operation system into the memory. Load the operation system to the memory, then run. So when the operation is working, the program and the data is both in the memory, only one memory.
Program and data both.
Just is my PC, only one memory. But your phone, maybe you two memory. Yeah, two memory is one new man. You should you should remember one Newman and Harvard,
Architecture.
and tell this difference.
Data and program are stored in same memory, and data and program are stored in separate memories. It's two different.
Just
Harvard
different.
tell us separate memories, and they von Neumann tell us same memories.
Same memory. Good.
What's the example of Harvard architecture devices?
You want some example?
Yeah.
The PC, only one memory. The PC, only one memory. Your phone,
Two memories.
two memories.
This is a different. Von Neumann's one memories and
Harvard architecture has
two memories.
two memory.
Like
We call the two memory RAM or ROM.
ROM.
You know RAM or ROM.
Random access. Subject and destination.
This is a major computer architecture. One Newman architecture. Only one memory. Harvard architecture has two memory: instruction memory and the data memory. This is a PC. Your personal computer. This is your phone. Your phone have two memory. Many family machine, your washing machine, your refrigerator. Is on two memory. Is commanded by the single chip microcomputer. Computer programming language. Computer language, when the computer is invented, is commanded by the machine language. Just consists of 10 code.
Binary code.
Machine program consists of a sequence of machine instruction. A machine program can be executed by the computer directly. The hardware can read 10, but your program is programming by the 10, so the computer can directly read the code. Read the code. But the programming productivity is extremely low. It's for some. It's very hard for someone to make a big program. If you have to your reference book, you find some code and write one code. So you find that it's very
hard.
Very hard. Yeah. You never remember all of the codes. Yeah.
No, it's have a rules and regulations, easy way to code it.
Yeah.
But for first timers, it was very hard to
Yeah.
understand.
Yeah. After they invented the assembly language, so the programming is easier. A little easier. Easier. Consists of assembly instruction. Assembly instruction is different than the machine code. Is some symbolic name, just like this one. Yeah.
Yes.
This is the machine instruction. Just consists of 0, 1, 0, 1. Yeah. Assembly instruction is this is symbolic. Yeah. Yes. This is opcode. This is operand. Opcode operand. Yeah.
Oh yeah.
Yeah. Opcode operand. Yeah. If you make a program, you know use which opcode.
Yes.
Yeah. You know.
We can use instant 0, 1, 1, 0, 1, 1, 1 instead of MOV.
MOV.
Yeah, we can use 0, 1, 1.
If you want to use this one, but you have know the input device. Yeah. Many years ago, the computer have a device can read the 0, 1, but now we have no the devices. If you want to use the 0, 1 machine instruction, after we make a program by the assembly instruction, the assembler, a program help us convert the assembly instruction into machine instruction. So the computer know your code. Assembly program is a sequence of assembly instructions. Assembly program must be translated into machine program. Before it can be executed by the computer. The translator for the assembly program is called an assembler. Assembler. Is a program. Yeah. Programming productivity is also well known, but is easier than the machine code. Machine code. Yeah. Any question?
No.
This is a high-level language. Yeah, high-level language. Which means the machine's code and the assembly is no-never language. No and never language. Yeah, this is.
Oh, lower level language.
Noah.
This is high level language. Yes, let's understand.
There's a high level language must have no level language. No level language.
This is
yeah.
lower level language.
No language. Yeah. No level language is not it's inconvenient for us to use.
Yes.
Yeah. So the scientists invented a high-level language.
Easy to use and convenient.
Yeah, it was easy to use. Yeah. Invented to improve programming productivity. Yeah. Programs written in high-level language are either compiled or interpreted. Is compiled or interpreted. There's two function. A program written in interpreting language required an interpreter to execute the program. The interpreter performs the operation specified by the program without translating into machine instruction. Language just like basic Lisp, Python, Java are all the interpreting language. You have you heard the language basic?
Yes.
Python? Yeah.
Python.
Yeah. This is interpreting language. Interpreting language is very easy to use. If you want to learn something, it's easy.
But for machine learning, I think Python is better than other languages.
What language?
For machine learning.
Machine
language.
Machine language.
Yes, machine learning.
Oh, machine learning. The AI?
Yes.
You mean AI?
Artificial intelligence.
Yeah, AI. Python is use the AI. Yeah. Program written in compiling language requires a compiler to compile the program into machine instruction. Yeah. If you write a program in compiling language, before you can use it, you must compile the program into the machine code. In the computer, the machine code marked as EXE, EXE, yeah, extensive name. Before they can be executed, language such as C, Fortran is a compiling language. C, Fortran and compiling language. And this language, if you compiling to the machine code, the fast running very fast. So if you want your program running fast, you must compile it to the machine code. But the interpreting language is running slower than the compiling language. Next, we tell something about the type of the computer. Mainframe computer, mini computer, microcomputer, and personal computer, cell and supercomputer.
So our university has supercomputer.
What?
Our university has supercomputer.
University?
Yeah.
You very computer?
No. You have any supercomputer?
Sorry.
Supercomputer.
Supercomputer?
Yes. Our university have?
No supercomputer. Supercomputer is very expensive. Yeah, expensive. Yeah. Do you know Hunan University?
Yes.
Yeah, Hunan University, there's a supercomputer.
Oh my.
Hunan University. Yeah, very big. A house. A house is stored this computer. Yeah. Mainframe computer. The earliest computers are called mainframe because they are made of vacuum tube and are huge in size. Do you know vacuum tube?
Vacuum tube.
Yeah, vacuum tube. Some made of glasses. Yeah, middle of glass is the electronical trust move in the glasses. The mainframe computer is very huge. Very expensive. So only large organizations and company can afford them. Very expensive. Also used to distinguish high-end computer from less powerful computer. The mainframe computer means high-end computer. High-end computer is very expensive. Mainframe computer has a lot of storage, serving simultaneous many users through terminal stations, which means one computer can be used by many users. Yeah, they can access the computer from the different places, just like the supercomputer, because the mainframe computer is very expensive. They cannot use by one people. With many people, you can use
from different places and then use their storage.
Yeah. Just like the supercomputer.
Yes.
Your PC, your PC has a remote desktop.
Do you have any idea how much price is a supercomputer? Do you have any idea how much price?
How much price?
Supercomputer price.
How much?
Yeah.
You want to buy?
No. Just idea, just idea.
Just curiosity.
Just asking for just curiosity.
Different level computer has different prices. But commonly maybe 4,000 yuan.
4,000?
Yeah, 4,000 yuan is computer, PC computer, not the supercomputer.
No, I mean supercomputer.
You want supercomputer? No. Maybe 10 million.
10 million yuan?
Yeah, maybe 10 million.
10 million yuan.
2 million yuan. Maybe. It's very expensive. When you use a supercomputer, the computer needs many power. Yeah. So if you power on your computer, the power of this city come to this computer.
Yeah. Oh my god.
It's not good. Yeah. Mainframe computer has a lot of storage, serving simultaneously many users through terminal station. And do you want to have a rest? Yeah.
Because I'm just converting the price.
He's converting the price. Supercomputer price.
Supercomputer price.
Convert money.
Compare.
Change money.
Exchange. 10 million RMB. Exchange and convert. Okay, I should leave it then.
Okay, we have a rest. Okay. I have a rest.
Yes.
Continuously, many users through terminal station, so many people can use one mainframe computer. The CPU time is divided into slots, with each time slots assigned to one user. Maybe you cannot understand this sentence, which means when the computer work, the computer separates the time to many little interval. One interval or not work for one user, which means if you four use one computer, the CPU separates the CPU time into three slots. One slot for you, one slot for him. Yeah. But if you feel, but you feel the computer is just working for you. That's working you. But actually, a computer is working for people. This means just like the parallel computation. You know, parallel computation.
Parallel.
Yeah, parallel. Yeah. Just like you have 4 computers work for everyone. Yeah, parallel calculation. Parallel calculation.
Yeah.
Computers.
Yeah.
It's like this.
Just like this.
Like this parallel computer.
This is the computer.
Computer, yeah.
Yeah.
Yes. Yeah. Parallel computer.
Computer. Yeah.
Yes, understand. It's like a chain. Parallel.
One little interval. The computer separates the interval to 3, just like this example. Separate the one interval to 4 interval. One interval work for this one. One interval for this one. Yeah. Computer work for everyone just for a little while. Yeah, very short time. Work for him. This is it's a period. You can understand what I say? Yeah. Sorry,
Yes.
maybe I'm not clear.
No, see.
Yeah. This is a parallel calculation. Maybe your computer have 2 or 4 core. Do you know? Your computer, your 2 core computer. Yeah. This computer only 1 core, but it needed to work for 4 people. So the computer separates the interval, 1 interval to 4 interval, work for different people. The user feel the computer is working for him. Yeah, they don't know the people, the computer working for other people. Yeah. So if you have anything about this, you can ask me after class. Okay. Okay. Mainframe computer market is dominated by IBM 360 compatible product line. This is widely old computer. IBM 360.
Maybe this company first invented computer. IBM company.
Very fast.
No, IBM company.
IBM. Yeah. IBM is
first invented computer.
Yeah. IBM 360 was introduced in 1965. User can start small and upgrade later on. It means if you buy IBM 360, you can buy less hardware. When you think you can afford the upgrade, you can buy more hardware. More hardware.
It's small. Hardware is small.
More hardware make your computer more huge.
Yes, yes.
Yeah.
Yes, maybe when the first invented computer, it was too big.
Too big.
Hardware is too big.
Yeah,
But
yeah,
day by day, this hardware is small, control, microcontrollers.
Yeah. The IBM 360 computer are software compatible and can run the same program disregarding their memory and performance. Which means the program you write by for other computer can run on the IBM, can run on the IBM 360 computer. In 1970, IBM 370 was introduced as the upgrade for the IBM 360 family. IBM 390 was introduced to replace IBM 370. The latest IBM mainframe family is the System Z, but is that now the IBM computer is not used for the people. This is out of time. It's out of time.
Yeah,
it's out of time.
But they are the boss. Fast.
Yeah.
Yes.
Now computer is faster.
Yes.
This computer system can run the same software. It's a mainframe computer. The future of mainframe computer: firstly, high reliability and security through reductant design. Do you mean the reductant design? For example, your computer has two CPU. Two CPU. Just one CPU is just one CPU work. When the one CPU is dead, other CPU work. Yeah. This is a reductant design. Two system, two hardware.
Processing unit.
Make the computer higher reliability. Our plan, our plan has two engine, two operating systems. Yeah, two operating systems make it higher reliability. Compatibility is guarantee the success of the product. Many programs used on other computer can run on the mainframe or computer. So this is a feature make the mainframe computer is popular. High utilization rate support massive throughput. Rarely went down. It's working day and day, maybe weeks and weeks, never broken. Repairs and hardware upgrades can take place during a normal operation due to reductant design. When the computer is working, you can replace the hardware. But your PC, your personal computer, you cannot do this. Yeah. Next, we introduce the mini computers, smaller than mainframe computer in size and were introduced in 1960s. Smaller by using transistors, core memory, and integrated circuit. Earlier mini computers took up one or a few cabinets of a large refrigerator. Yeah, refrigerate took up one or a few cabinets, just like the size or refuge, or 2 refuges, 3 refuges, maybe a little bigger than our personal computer. The first successful mini computer was introduced in 1964 by DEC, computer. Major mini computer vendors include Apple Computer, Data General, DEC, WHIP, HP. Now HP exists. Packing, Airman, Prime, and One Laboratories. Starting from late 1960s, the 7400 logic ICs were used in mini computers. 1980s, mini computers used VLSI chips, which means very large scale integrated circuits, which means we can get the computer smaller, integrated the many parts into one chip integrated. In 1980s, many mini computers become 32 bits and were called super mini computers. DEC is the most successful mini computer company. Mini computers were forced to dance by PC and servers, which means personal computer and servers killed mini computer. Microcomputer. A computer that used a microprocessor as its CPU. Microcomputer, our personal PC, is microcomputer. Yeah. This first batch of microcomputer appeared in 1970s. The earliest microcomputer came with as little as 256 bits of memory and no I/O devices other than LEDs and switches. The earlier microcomputer is very simple. Yeah, very simple. The memory is very small. No LED, no keyboard, just a main machine. In the middle 1970s, microcomputer grew faster and cheaper. The Chromical and Electros are among the most successful microcomputer company. This company maybe is in America. Microcomputers were used to run business applications such as accounting, database management, and word processing. We know our personal PC can working as accounting, working as database management, or you can use the computer, edit some paper, some text. This is normal for a microcomputer. Some microcomputers were single user, others are multi-user. Some microcomputer, if your microcomputer has a has a several use operation. Do you know several use operation? Now we use the Windows 10. Do you know Windows 10?
Yeah.
Yeah. And Windows Server, if you install the Windows Server on your personal computer, your computer can be used by many people. Yeah, they can access the computer from the internet, from different place to different. Apple II was introduced in 1977 and became one of the most successful computer in the history. Then everyone knows Apple. Everyone knows Apple. Apple II has many clones due to its huge success. Macintosh, introduced in 1984, was the successor of Apple II. If you have enough money, you want to buy a Mac, do you know? Yeah. But the Mac is expensive. Mac has gone through several generations and has used several different microprocessors, including Motorola. It's a Power PC and Intel Pentium. This is it's all the model of the CPU. It's all the model of the CPU. Mac has many forms: desktop, laptop, and all-in-one. You have a computer, is desktop computer or laptop computer? Laptop computer.
This is laptop computer.
Oh, your laptop computer. Yeah.
And this is desktop.
Yes, desktop. Yeah. Good. You can understand all this.
Yes, that's it.
I was glad.
Please. The previous class, what is the example of all-in-one?
All-in-one. Just like the combination of desktop and laptop. Yeah. Now, you have some laptop. You can plug in a keyboard. Now you can put the laptop as a LED in front of you. You can use the keyboard just like a desktop.
Oh.
Yeah, just use a desktop.
We understand.
Yeah.
This PGA cable or HDMI cable, you can connect a monitor's the screen and you can control the laptop and its screen. It's all in one. That's good. We understand.
IBM PC was introduced in 1981 and used the Intel 8088H as its CPU. 8088 is a very old CPU. Yeah. IBM PC used off-the-shelf component OS from Microsoft. IBM PC was a big success and has many clones. At the end, there are more IBM PC clones than the original IBM PC, which means the IBM PC is popular. Many people fake the IBM PC, making an IBM PC. The old PC has been used to refer to IBM PC compatible. IBM sold its PC business to Lenovo in December 2004. Do you know the Lenovo, a Chinese company? I don't know if it's a Chinese company, but Lenovo is famous in China.
Nova.
Lenovo. You know Lenovo?
Yes.
Manova is a big company. Yeah, but I don't know if Manova is belong to China. I don't know.
Lenovo, yeah.
Lenovo. Supercomputer, a computer with the speed of computation at the front line. The big supercomputer was introduced in 1960 by CDC and designed by Seymour Cray. In the 1960s, the supercomputer only ran instructions much faster than the other types of the computers. In 1970s, most supercomputers are vector processors in which one instructions can operate on multiple data items, which means one instruction can operate on multiple data items. It means one instruction to many data at the same time. In the earlier and mid 1980s, saw machines with a modest number of vector processors working in parallel to become the standard. Means parallel. Many small work at the same time. Many small many CPU work at the same time. Now the supercomputer has thousands CPU. CPU. The CPU can work together, so the supercomputer is faster. Supercomputer is faster than the personal computer, not because the CPU is faster, because the supercomputer has many CPUs. Many CPUs, yeah.
Super CPU, central processing unit.
In the later 1980s and 1990s, attention turned from the vector processor to massive parallel processor systems made of thousands of either off-the-shelf ordinary commercial microprocessor or customer microprocessor. Thousands of microprocessor. These microprocessors are grouped into cluster and connected using the custom interconnector, which means that these microprocessors work together. US is the leader of supercomputer field at the beginning. Japan made major strides in the supercomputer field in 1980s and 1990s. In 2010, the Tianhe-1 became the fastest supercomputer in the world for 1 year. The Tianhe-1 is Tianhe-1 belongs to China.
Chinese company or
belong to China. Yeah. But the Tianhe-1 became the fastest computer in the world for 1 year, only 1 year. In 2011, Japan's Fujitsu key computer became the fastest computer for 1 year, which means that a supercomputer is become the faster, become faster. In 2012, 2 US supercomputers held the crown. In 2013, China's Tianhe 2 became the fastest computer for 3 years.
Oh, 3 years.
For 3 years. In 2016, China's Sanwei Taihu Light became the fastest supercomputer and held the ground for 2 years. Sanwei can perform 93.01 Peter floating point operation per second, which means the computer is very fast. Very fast. In June 8, 2018, IBM Summit takes back to the crown of the fastest supercomputer again. The Summit can perform 122.3 Peter floating point operation per second. IBM is the oldest computer company.
And was again coming.
They have the enough technology. So the technology is very high technology than other computers.
Yes. Because they are boss of computers. First they invented computers.
So the IBM has a plan for the quantum. Do you know quantum computer? 量子计算机，听说过吗？ You have had 量子计算机。 English is a quantum computer. Quantum. I don't remember how to spell these words. The quantum computer is different from the normal computer. I check on the dictionary. Okay.
Why was sleeping? Anta? You can sleep.
It's a quantum computer.
Quantum.
Yes,
Lavshi. Understand? Quantum theory. Chemistry.
Quantum.
Yes,
Quantum computer.
We have a theory, quantum theory.
Quantum
theory. Yeah. Like this. Quantum theory.
What was the difference between quantum computers and other computers?
Quantum computer is from the quantum interaction. The normal computer has two bytes, 1 0. But the quantum computer maybe have 4 or maybe more states. If has if 2 quantum get the interaction, and even the distance is very very much. It is very much. Just like one quantum is on the moon, one quantum on the Earth. They can get the same move. Can you understand? Quantum interaction don't care the distance, so they can work very fast, very fast. This theory, I can tell you, the theory is quantum interaction. Two quantum, they can act the same action. Whatever the distance is, don't care that. They don't care the distance. The quantum computer, if they can make the quantum computer work like a personal computer, this will very amazing. It's very amazing. They can work faster than the computer now. Yeah. We know something. If you encrypt some data on your computer, encrypt. Use the normal computer decryption. Maybe you take 10 years. 10 years. But if you quantum computer, maybe 1 second. Maybe 1 second. So quantum computer is very fast. The IBM maybe get the quantum computer work as a normal computer, maybe. Application of supercomputers, computation intensive application. While the forecasting, while the forecasting, they can connect many data and predict the weather. So you must calculate the data very fast and get the result as soon as possible. As soon as possible. Climate research, quantum mechanical physics, use the supercomputer research the quantum mechanical physics. It's quantum. That's quantum.
Yes.
Quantum is mysterious. Quantum is mysterious. Molecular modeling structures, properties of chemical compounds, macro molecular polymer and crystals. It's about the structure, material, chemistry. Chemistry. Structure, material, chemistry.
In chemistry, they have a quantum theory.
Quantum theory
is in chemistry.
In chemistry. cryptanalysis. This cryptanalysis means corruption. Weapon simulation, nuclear power simulation, or others. These are the application of supercomputer.
Now see, our university have nuclear engineering subject.
Nuclear engineering.
Subject our university.
No, maybe no. I don't. Maybe we don't have the nuclear engineering. Yeah, no. I don't remember we have this the nuclear engineering. Yeah. If we have the nuclear engineering, maybe it's must be secret.
Secret.
Yeah, secret.
Yes, understand.
How to make a supercomputer faster? Implement pipelining to the ALU. Issue multiple instructions in each clock cycle. Issue multiple instructions in each clock cycle, which means in one clock cycle, two instructions can work. Normally, one clock cycle, one instruction. If we can make the computer work two instructions, is faster. Use the fastest microprocessor if possible. Not necessary anymore. Use the weak processor that has SIMD compatibility. Use a cluster of multi-processors. Each cluster may have from 60 to 40 commercial microprocessor, which means we can use more CPU. Use faster interaction network to connect cluster of processor. And many supercomputer connect each other. Use the interaction. Maybe interaction is faster than other transfer device. Use I/O system that support high bandwidth. Which means the I/O system has wide transfer tunnel.
Yes.
Transfer tunnel.
Bandwidth. That's speed.
The processor. We tell something about the processor. Arithmetic logical units perform arithmetic logical operation. The processor includes the ALU register control unit. Is the ALU register and the control unit consists of the processor. The ALE performs arithmetic logical operation. Register used as operand of introduction. One of the register is the program counter, which keeps track of the address of the next instruction to be executed. In the processor, there are many registers. They store the operand. They store the operand. Control unit decode the instruction and generate a signal to control the ALU and other parts of the computer as a control unit. A simple ALU example perform only add, sub, and or operation. This is a diagram. This is a diagram tell you the relationship of the register. This is the opcode. This picture tell you the relationship when the add, sub, and or. Maybe you don't know how they do the work. We don't know, but we don't care. You know something. The ALU is a key part of the processor. This ALU is a key part.
This is adder, this is carry bit, XY, sum carry 1.
What?
Now see, this is adder. It has 3 input. Sum carry.
This tell you the logical relationship. Logical. For example, and is and. Do you know and? And means I don't know.
This is the AND gate.
AND gate. Yeah. AND gate. You know.
You can use in circuit.
Yeah. Yes, AND gate is OR gate. Yeah.
OR
Yes, OR
gate.
gate. Yeah. Use the hardware or logical operate the add, sub, and or. Yeah.
So when we design circuit, we can use AND gate or gate.
Yeah.
Circuit design.
Yeah. CPU register. CPU, there's many registers in CPU. Very close to CPU, used to speed up the ALE operation. The register, the biggest register make the CPU work faster. CPU has a small number of registers from 8 to 256. Some processor add a special register called accumulator. Most ALU instructions include the accumulator as an operand number. When there are many registers, computer designer know any register to be used as many operand in most instructions. This is called orthogonal. Maybe my pronunciation is not good.
No, we understand.
Yeah.
We understand. Great.
Yeah. Control unit. The control unit reads in an instruction, decodes it, and generates a sequence of control signals which activate appropriate part of the computer to perform the operation specified by the instruction. The control unit read instruction, decode instruction generates control signal, which activates appropriate part of the computer. Activates, perform operation. This means control unit. Read, decode, generate, and activate. The processor uses a special register called program counter to keep track of the address of the next instruction to be executed, which means the program counter remember the address of the current instruction, and if they add 1 for next instruction, the program counter remember the address, just like the door address. Remember this one, we can know next one, just +1. That's +1. When the processor fetches an instruction from memory, the program counter is incremented by the size of the instruction. A clock signal is used to control the pace of instruction executing. The clock signal is faster. The computer can working faster. So the speed of CPU is decided by the clock signal. Programming execution is not always sequential. This means when we execute the program, we can jump from here to there. We can jump. Program execution is not sequence. Processor may need to change the order of instruction execution based on the value of certain condition, or due to the need to repeat a sequence of instruction. This is called program flow control. Just like when you program if something, then something, if something, then something, or you can for repeat doing something. Yeah. The condition for the processor to make a decision whether to change the flow of instruction execution are stored in the status register. As a register. Program flow change is implemented by conditional branch or unconditional branch instruction. Branch means jump. Branch instruction may specify the distance to jump to, or the address of the destination to jump to. Branch instruction specifies the distance to jump, or to the address. Tell you the distance to jump, or the address to jump. Next, we tell you about microprocessor. Is a processor implemented on a single VLSI chip. A microprocessor does not have on-chip memory. Peripheral functions such as timer, AD converter, DA converter, accumulation intervals, and so on. Microprocessor, like the personal computer CPU, personal computing CPU, they don't have on-chip memory. They don't have timer. They don't have AD converter or DA converter. They don't have the communication interface. They don't have just a CPU, just a CPU. Because of this limitation, a product designed with a microprocessor cannot be made as compact as might be designed. This means if your CPU, if you want the CPU can work, they need the many devices, so they cannot make the device together and become smaller. So the microprocessor sometimes they don't suitable for some small device. This is the microprocessor. Is a personal computer CPU. This is a microcontroller. Microcontroller is the main topic of our class. A microcontroller incorporates the processor, memory, and many peripheral modules into a single VLSE. It means many functions are integrated into one chip. SRAM and flash memory, peripheral such as timer, parallel I/O part, serial communication interface, AD converters, DA converter, and so on, are often included in a microcontroller. This means microcontroller has many functions. Flash memory is used to store program memory, whereas SRAM is used to hold dynamic data. We know the microcontroller has two memory. One memory for program, one memory for data. When you write the program into the memory, the program cannot be modified. But the data memory can be modified anytime. If you lose the power, the data disappear. Okay, I see you all tired.
Yeah.
We can have a break. Okay.
তোমার জন্য ব্রেক পাইলাম